Hello and good evening. Welcome in this session on MATLAB tutorial series. Today in the session we are going to cover order differential equation with MATLAB. Order differential equations play a very important role to solve different type of problems in various fields including physics, chemistry, engineering, biology, economics and more. Here are some applications. ODE are used to describe the motion of objects such as position, velocity and acceleration of a moving particle. It is used to describe the behavior of electric circuits such as charges and current flowing through the circuit. It is also used to describe the rate of chemical reactions which can be used to design and optimize chemical process. ODE also is used to model the severity of infectious disease and the effectiveness of public health interventions. ODE is used to describe the changes in the population size and over time, including birth rate, death rates, and migration rate. ODE is used to design controller that can regulate the behavior of the dynamic system. ODE also used to model the behavior of the stars and galaxies. It is used to describe the behavior of fluids such as the flow of air around the airplane wings, etc. And along with the computing with the MATLAB, the ODE or PDE play very important role to study various type of problems when the problem is very complex. And sometimes we need to compare these results with the existing problem and the various type of ongoing problems, and that's why we need computing. And along with there are several softwares for the computing like MATLAB, Python is also there. We can use Scilab, Mathematica, Maple. Octave is also useful to solve this type of problems. In the present session, we are using MATLAB because this is complete series is based on MATLAB. So I hope the content which we are going to present in this session will be very helpful for the upcoming sessions. Several examples has been introduced in this session to cover various type of problems, how we can use this MATLAB to solve this type of problems. Now I would like to share my screen with you. So this is the you can see my desktop is visible to all of you. Just 1 minute, please. Okay. Just 1 minute, please. Yes, good evening and Vani Madhvi. Okay. Thank you very much. I think my voice is perfect audible to all of you. Okay. So this is the presentation. And these are the content which we are going to cover. Sorry. Yes, good evening and Vani Madhvi. Okay. Thank you very much. I think my voice is perfect audible to all of you. Just 1 minute, I have to reopen the file. Okay. Just 1 minute, please. Just 1 minute, I have to change the file. MTTF MATLAB. Yes. Okay. Sorry for the interruption. Actually, the file was on the other system. That's why. Okay. Yes. So this is the. I have to choose. Okay. So here, so first we are going to create a symbolic function like sims yt. So you can see here sims yt will create a symbolic function which is involving for that differential equation. Okay, and you can see double equal sign. Double equal sign is used for the diff is inbuilt function differentiation, and as you see, y is function of t. So we here differentiate y, we solve ODE. And when you will enter this very first statement, the MATLAB, here if you are willing to create a script file, we can create the script file, or either we can use direct here. This is the command window sims yt. Okay, first we need to declare the symbolic variable. Then after we have ODE is equal to, so the differential equation will be stored at this place. ODE is equal to diff, and here is y comma t. Okay, then we have to use at this place double equal sign, which is used for the equal, then t product y. Okay, so this is the differential equation, and when you will enter, this will return the above differential equation, and the information we input at this place are correct. Now we can find out the solution of this differential equation, and we want to store the solution of this above differential equation in this assignment. This is nothing but the assignment for the solution which we are using here, and as you know, D solve DSolve is inbuilt function in the MATLAB to solve differential equations. Okay, so ODE, this will return the solution of the above statement. And you can see here is the solution. Y solution t is equal to C1 and product exponential t raised to power 2 upon 2. So in this way we can easily solve the differential equation, and also if it is required we can write the script file because many different type of operations are required to find out the solutions, and their graphical interpretation is also required. So the thing is, when we are entering the statement in the command window, and it is not easy to control the statements, that's why we need to create a script file. CLC is the command to clear the command window, and clear is used to the all the variables from the workspace. Control plus N. I am going to save this file with the name of ODE1 and store this file on new folder. We can create here new folder on the desktop, as you can see. Right click, then a new. Okay, and this is the computing ODE. Okay, and enter. So now double click on it and save it. So you can see this is the path for the same. Editor, C, user, and so on. Okay, the file is saved in this path. If you want to open the same, you can go from this place and go to the desktop and computing ODE. Okay. Yes, you can see the file is saved in this current directory. Okay. So here, as you know, we are using CLC to create the command window, and then we have clear. Then you can close all. So this will close all the windows of the MATLAB which will be opened at this place. Okay. So here we are creating the script file. And also, if you are willing to write the script file for different type of problems, and you can create cells at this place also. See here, this is double percentage I am using. So this will divide the script file into several sections. Okay. So here solve ODE without condition. Okay, without condition, and then we can write here the statements. Then you can write here sims yt. Okay, this is yt, and then again we have the differential equation ODE is equal to diff. This will help you in many ways because it will save our time. We want to say differentiate y with respect to t, and then double equal sign. Okay, and t product y. Then semicolon is used to suppress the statement. So when we are using the semicolon, this will not return the value. Okay, only the information which we store at this place will be saved in the assignment ODE. Then we want to solve this differential equation. Y solve for t, okay, will be equal to, this is the solution, DSolve. DSolve function will be used, and this will solve the differential equation ODE. Okay, and also I let you know the percentage is used for the comment. Okay, so here we are going to solve the differential equation dy upon dt is equal to ty, and we don't have any initial conditions or the boundary conditions. So now you can see we have created a very beautiful sketch file, and whenever it is required, you can use in future also. Okay, so when you want to execute this cell, you can just click at this place, run this section. Okay, so this section has been created. Either you can press this run section. Okay, and when you will enter, you can see we have the same solution at this place. You can see. So in this way, you can write easily the several programs in the MATLAB and create a script file for your future use, and this will help you in many ways. If you have any question related to this, you can put your questions in the live chat box, and I will try to justify your questions. Okay. Thank you. Now, what if we have the initial conditions for the same? Okay, this problem was without initial conditions, but when we have the initial condition, then how we can solve? Yes. Yes. So if you can see C1 was the constant and we want to eliminate C1, and when we have the initial condition, we have to apply that particular initial condition, and you can see here y0 is equal to 2. This is the initial condition, and we need to apply in our this problem, and this is very quite simple to apply the same. Here is the condition on the MATLAB code. You can see COND, this is the condition, is equal to y0, and double equal is used for equal. Y0, when we have t is equal to 0, the value of y is 2. And this first condition for the single order differential equation stored in condition, and again we are executing the same statement, y solution t is equal to d solve ODE comma condition. So when you will execute this statement, this will return us the solution, okay, after applying the initial condition. See, in the MATLAB, what we are doing here, we have the condition also, okay, and condition will be applied at its place to find out the solution, and see here condition is equal to, we have y0, okay, this is the initial condition, is equal to, we have this was, sorry, this was, the condition was, okay, 2 is equal to 2. Yes. And then we need to pass this value at this place, this condition, and when you will execute this statement, you can see in the previous solution we have at this place C1, and now we have the condition which is being applied at this place. Use semicolon. As you know, semicolon is used to suppress the statement. Okay. Again, when we will execute this statement, yes, you can see the constant at this place has been eliminated. Okay. Now we have the solution which is after applying this condition. So in this way you can solve the ODE with the condition or without condition, both the way. And I hope this will help you how you can apply the conditions. Someone is asking, Vani Madhavi, can we write the condition in the next script or in the same window? Yes, we have to write the condition along with because the thing is, we need to apply at its place. Okay, if you are thinking that first you need to do the solution, okay, you can do in this way. Just 1 minute. I am doing here. You can do in this way also. Copy and paste at its place. Then yes. Display. You can do in this way. Display solution without condition. Okay, and then we have display y and SOLT. Okay. So when you will execute, see what happen. So this is the first solution, and C1. Okay. C1 exponential t raised to power 2 upon 2. This is the solution without condition. And similarly, you can use for the same at this place. Now this is the second part. This is the second part. Applying the condition. Applying the condition. Applying the given condition. Okay. Applying the given condition. So note these statements how I am doing. So this will help you. So here we are going to apply the condition. First solution was without the condition, but here we are going to apply the condition. Okay, and yes, this one solution with condition. With condition. Sorry. Yes. So when you will execute, you will see that both the solution will appear at its place. We have two solutions. Say in the command window. This is the first solution, and this is without condition. Okay. And then we have the second solution, which is with condition. Okay. So both the solution we can get by applying in this way, with the condition or without the condition. You can remove this statement and copy from this place, cut and paste at this place. So it will be more beautiful and more suitable. Solution with condition, sorry. Okay. Yes. When we are using a semicolon, this will suppress the statement, as you know. Yes, now it is fine. Once again, check it. Yes. So this is the first solution. You can see solution with the condition, without condition, we have this one. And solution with the condition, we have this solution. Okay. So if sometimes you need the solution, both type you can use in this way. And you can manipulate the sequence of statements according to your choice, how you want to manage your programming for your use. I think your question is very clear, and anyone have any question, please always feel free to put your question in the chat box. Okay, now we are dealing the next new example. Just 1 minute, I have to open in this way. Yes, because I have to explain many things. So yes, and okay. So this part has been discussed. This also has been discussed. Solve the differential equation with condition. This part also has been discussed. If we have nonlinear differential equation with initial condition, then how we can solve this type of problem? Okay, see here. We are given this differential equation dy upon dt plus y square is equal to 1, and this is the condition y0 is equal to 0. Okay, so this is a same way but different. So first we need to define here symbolic variable. This differential equation is involving yt. So first we need to declare this symbolic function, and then we need to proceed. Okay, so first we need to store this differential equation in one assignment ODE. ODE is equal to, see carefully and compare this statement with the MATLAB syntax. This is the same as we have. This is the first order derivative. This is the first order derivative, and we write the same in MATLAB. This is the statement diff y comma t. This is the first order derivative with respect to t. Then we have plus y. Here is y. Close the parenthesis, and then we have 2 cap 2. Then double equal means equal. The meaning of double equal means equal 1. So this differential equation has been stored at this place. Now we are thinking about how to write the condition. This is the condition, and we store this condition in this statement. Condition is equal to, single equal is used to for the assignment. Okay, so this condition has been assigned to this variable. Okay, so y naught double equal 0. So this is written as in the MATLAB code, use double equal sign 0. Okay, so this has been stored in this condition. Now we have the same process to find out the solution. Okay, and you can see here we are using the same statement. Y solution t is equal to d solve ODE, and then we have the condition. When you will execute this statement, when you will execute these statements, you will have the solution, which is at this place. You can see this is the solution, and this is differential equation has two solutions. One is this one, okay, and this is the another solution. This will return us two solutions. Okay, so in this way we can use to find the solution. And if you want to write the code in the MATLAB, this is also very interesting. And let you know one more thing. We will create, we can create multiple codes for different type of prompts in this script file. So how you can use? Okay, the important thing is how you can use this script file for your multiple sections in the same file. So here when you will enter double percentage sign, okay, new section will be created, and here we will assign the statement, which type of problem we are going to discuss here. Okay, so here we are solving the nonlinear differential equation. Okay, this is the with initial condition. We have the initial condition also. So in this way you can easily write your script files and you can save for your future use. And the code is, we have first we need usually we are using CLC. Use first CLC, then clear, then we have close all. Okay, so these are common to all the script files and the sections. Then we need to first declare the symbolic function and sims yt. Okay, sims yt, you got it. Then enter, and first we need to store the differential equation ODE. We have diff, then y comma t. This is the first order derivative with respect to t. Then we have plus y. Okay, and cap 2 is equal to 1. Okay, then we will suppress this statement by using semicolon. Okay, and we have the condition. Condition is equal to, we have y0 is equal to 0. This is the initial condition which is given in the statement. Okay, then we want to find out the solution, and that will be stored in this place, y solution t. Okay, the solution will be in terms of t, and a is equal to, we have d solve function. D solve function will be used at the place. Okay, and then what should be there? ODE and comma condition. Okay, two solutions. See carefully. So these are the two solutions which are appeared at this place. Okay. So as we do in the previous file, you can do at this place also. You can manipulate in different way. Okay, it depends upon you how you want to return your values, your solutions. Okay, so this is the beginning of the journey, how you can use script files, how you can write your codes for the differential equations, and all these syntax which we are using at this place will help you in the coming sessions for the different type of mathematical models, and when we will use numerical methods to find out the solutions of this type of problems, whether it is ODE or PDE or system of equations. Okay, so this script file, how you can create and how you can divide the file into the several sections will help you in many ways. Okay, so now yes. Now we have the one more interesting example at this place. You can see second order differential equation with initial conditions. So in the first two examples, we just discussed about the first order, okay, for linear and non-linear. But here we are going to discuss about the second order, then we will discuss about the third order. Okay, how we can solve the second order differential equation when the initial conditions are given. But when we have the second order differential equation, you can see we have two conditions. This is the differential equation of second order, and we are given two conditions. Okay, so both the initial conditions will be applied. How we can do? First, we need to define the equation, then conditions involving the first order or second order. Then we need to create the symbolic function for the derivative also. Okay, so for this statement, for the second condition, we will use dy is equal to diff y for the second initial condition. Okay, so this will represent the derivative by creating the symbolic function, and we need to define here a symbolic variable, and you can see here y is function of x according to this given differential equation. So the symbolic variable will be yx. So in the very first statement, we have the symbolic variable or symbolic function, which is yx. Then we need this statement, okay, dy is equal to diff y. Okay, then this is the first order, or you can interchange the statements. I will explain later. So now we need to this differential equation ODE is equal to, this is the second order derivative. So second order derivative we can define in this way: diff y comma x. We are going to differentiate y with respect to x. 2 means second order derivative. Okay, for the first order we need not require any number, but for the second order or third order you can use at this place number. This number means representing the second order derivative of y with respect to x. So this expression d to y upon dx square is, the meaning of this one is d to y upon dx square. Okay, so this is the corresponding syntax in the MATLAB. Then we have double equal, and double equal is used for equal, and on the right hand side you can see we have cosine 2x and cosine 2x. Okay, 2 product x. If we have 2x, then in the MATLAB syntax this will be 2 product x. If you are using this one, there is no sense. This will create a new assignment or variable which is not exist in our program. Okay, then we have minus y. Now we have two conditions. So this first condition is written as, this is the condition 1, and condition 1 is y0 is equal to 1. So in the MATLAB syntax this will be y0 double equal is equal to 1. This is the first statement, and we are using semicolon to suppress the same. Then we have the second condition, and the condition 2 is dy. Dy is used for y dash. Okay, dy 0 is equal to 0. So these are the this is the corresponding program to the given differential equation with the initial conditions. After that, what you need to do? Now we need solution of the above, but the thing is we will store both the conditions at this place to solve. We are given here two conditions, so these both the conditions we can store in the single assignment in this way. And now we have the conditions, we have ODE. Now we want to solve this differential equation for x variable, and see, this is the statement for the same. Y solution x is equal to d solve. ODE conditions, okay, this will pass at its place. Okay, then when you will execute this statement, and after that we need to simplify. Okay, and when you will use the simplify function, this will solve the this solution. Okay, and after simplifying, you will have the corresponding solution of the above equation. Okay, so now we can try this process in the MATLAB. Sorry, what happened? Okay. Okay. We were discussing about just 1 minute. This is the third order, but we are talking about second order. Yes, we were at its place. Now, we are creating here new file, Control N, and save it, Control S. This is the ODE2. Okay, so the problem we have is we are using here double percentage solution of second order differential equation. Okay, and now for the existing problem we have since if you want to insert the statement at its place for your work, you can save the same syntax. But we will use here latex syntax. Okay, d2y upon dx square. In this way, you can write for your purpose is equal to cosine 2x minus y. Okay, and with the conditions you are given is y0 is equal to 1, and the second condition is we have y dash 0 is equal to 0. So this is the second condition, and now we can write the program for the same. So here is the same. Sorry, we have to use CLC, then clear, then close all, then close all. Okay, then since we need a symbolic function which is yx. Yx is initial condition. Yes. ODE is equal to, we have diff and y comma x, and we need second order derivative. So this is the second order derivative. Diff y comma x comma 2 is equal to we have cosine 2x. 2x will be written as 2 product x. Okay, then we have minus y. So this is the differential equation which has been stored in ODE, and then we have the two conditions. So condition one is equal to, we have y0 is equal to, we have 1. Okay, and then the condition number 2, condition 2 is we have dy. We are using here dy. The meaning of dy means y dash 0 is equal to 0. So this is the second condition has been inserted at its place. Then we need to store both the conditions in the single statement. Okay, and we will use a simplify function also. So you can comment at its place solve ODE for y. Okay, and simplify function is used to solve the solution. Okay. So the solution which we will get will be solved by using simplify function. So first we need the conditions. We need to store the conditions in one assignment in this way. This is the condition 1. Okay. Space condition 2. This is the condition 2 and suppress it. So both the conditions which we are given are stored in the conditions in the single statement, and then after we can find out the solution for x. Okay, we want to find out the solution for x, and this will be equal to d solve, and apply at this place ODE, then conditions. Okay, so when we will execute these statements, see first what happened. Yes, when you will execute this statement, the solution will appear in this way. You can see. Okay, so this is a very long solution, but we need to simplify. Okay, for the simplification, we are using here simplify function. So this is the purpose to use simplify function at a place. See, so everything we are doing with the solution, hands-on session, so that you can go to all the steps which are important, how we can use simplify is a function, and we want to simplify this assignment. Okay, copy and paste at this place. Now again execute the file. You can see we have the corresponding solution. So after the simplification, you will have this solution. Okay. Yes, and EZ plot. Y solution and enter. So you can see also you can plot the solution of the differential equation. After simplifying, you can if you need to plot, you can do by in this way. AZ plot is very simple statement for the graphical interpretation, and if it is required, you can use in the at this place also. EZ plot, okay, and so you can see when we suppress this above statement, and when you will execute, this will return only the graph of the solution. Okay. Yes. See, run the code. We have only the graph. We have only the solution of the differential equation in the form of graph, and the solution which you got is on the title. Okay. If you want to insert some more statements, you can insert here grid on. Okay. So see again, and now you can see grids are there in the graph. Okay. If you want to insert X label, Y label, you can do everything, whatever you need to for your problem. Okay. Can you put any question? dy function in the MATLAB? No. dy is not the function in the MATLAB. Canada Solar is asking about the dy is no solution in the no function in the MATLAB. Okay, see carefully. See here. This is the function in the MATLAB. Okay, so when we are using single equal, it means this information, this statement which is on the right hand side is stored in this assignment. This is the just assignment. Okay, you can use at its place y dash. Okay, you can use y dash. Then what you have to do? You have to use at its place y and dash. Okay, so this is the just only the assignment. There is no you can use any variable for the assignment. Okay, so these are known as variable assignments. Okay, ODE, condition 1, condition 2, all these are variable assignments. Thank you very much. You got okay. Yes. So I think it is very clear to all of you. Thank you very much to support me. Okay. Now, yes. Now here you can see we have the differential equation of third order, and when we have the third order differential equation, then naturally we have three conditions, and when we have three conditions, then how we can solve the differential equation. Okay, this is also very quite interesting and simple. We are given this third order differential equation. Okay, and u0 is equal to 1, then we have u dash 0 is equal to -1. This is the second condition, and this is the third condition. So here the new thing is, here is first order derivative, and here is second order derivative, and here is third order derivative. So first we need to create symbolic variables for this equation and for this equation, and this is very quite simple, as we do in the very first in the previous example. In the same way, you can use for this first condition, this is the notation. You can create the first order and second order symbolic functions for the these two conditions which are occurred in the form of first order and second order derivative. Okay, so this is the syntax for the first derivative condition, and for the second we have this is the syntax d to u. This is the only assignment. Okay, this is the only the assignment, and here you can see we have the second order derivative diff ux2. Okay, now we can easily write our program in the MATLAB. Okay, see, yes. So here is Sims. This equation is involving ux. So the symbolic function will be ux. This is the very first statement. Then we have du. This is the this is used for the first condition. Okay, this is the condition 1, and this is used for the condition second. Okay, so you can see this is the statement d to u is equal to diff ux2. Okay, then after we need to write the conditions with the differential equation. Okay, so ODE is equal to we have diff ux. This is the third order differential equation. Okay, we are given in this form is equal to u. So this expression is we have this one. and A is equal to U, that is at the place. Then first condition, we have the second condition. This is the same process. U0 is equal to 1. We have the second condition. Du0 is equal to -1. And this is the third condition. D2U. D2U is second order derivative, which we defined in the previous slide. Okay, is equal to pi. Okay, the pi is syntax in the MATLAB. Okay, and then all these three conditions we can store at this place in the single statement, in the single assignment, as we do in the previous example. This is the condition 1, this is the condition 2, this is the condition 3rd. Okay, and then this is the final statement. This is the final statement. U solution X, when we solve the this equation, this will be the values of U in the terms of X. Okay, so we have the solution of this differential equation involving X variable. So D solve, and this is a step you can see is similar in the all the examples as we discuss. And Canada is asking about the for some part of the script file we have the space, and for some no space. Does this matter? Yes, this doesn't matter. Okay, it depends upon you. You can give space, or if you wanted to, you can. Because in the MATLAB, if you have a space, this doesn't matter. Okay, so you can use according to your choice. Okay, see in the MATLAB. See in the MATLAB. Yes. So here, see, if I give space at this place. If I enter at this place also, okay, if I enter at this place, so there is no difference. This will return the same solution. See, you have the same graph, okay, and this space will not, doesn't matter whether you are using or not. Not required. You can do yourself, okay. If you have question related to this example, you can put to your question. And if you are saying to find out the solution with the MATLAB, we can do. Okay. So if we have the differential equation like in this way, see, we have the, so you should try, because the code in this file already exists. And now I am give you one more interesting question. If we have the differential equation like just 1 minute, okay. So we have this equation. 2x square and d2y upon dx square plus we have 3x. You can do by using the same process. See in the MATLAB, we are creating here new file and save this file with the ODE 3. This is the third example. So here first we need to define for the same CLC, then clear, okay, and then we have close all. Then the differential equation is involving, we have the example just for the your convenience. We have 2x square, then we have d2y upon dx square. Okay, then we have plus 3x and dy upon dx minus y is equal to 0. Okay, so this is the statement and we want to solve this equation. So the syntax for the same we have is, so first we have to define the symbolic function. The symbolic function will be yx. Yx is the symbolic function. Then ODE will be equal to 2 product x and product. Now the second order derivative, how we can use? We can write diff y comma x comma 2. Then we have plus 3x, 3 product x product diff y comma x. Okay, y comma x. Then minus y and equal to 0. So this is the differential equation and suppress is, and after that we want to find out the solution. Solution for x is equal to d solve. Okay, and we are using at the place ODE. Okay, so when you will execute this statement, this will return the solution of the above statement, and you can see when I execute we have the solution d solve ODE. Okay, so this is the required solution for the above statement. And C1 and C2 are the constants. Here is also x square. Don't forget x square. Yes. Now try again. So this is the solution for the above differential equation. Okay, C1 upon 3x plus C power 1 by 2. This is the solution. Okay, you are not getting my voice? Vani Madhvi. Okay, fine, and please submit your questions. Okay, thank you very much, and I think you are getting my voice. Please let me know, are you getting my voice? Is there any problem? Please reply me in chat box. Okay. So here you can see we have the your place. Okay, thank you very much. Thank you very much. Thank you. So now we have the system of equations. When we have the first order linear differential equations, system of first order linear differential equations, how we can solve this type of problems? This is also quite interesting, as you can see here there are two symbolic variables. So first we need to define, okay, in both the equations u and v are functions of t. So these are the two symbolic functions. So first we will define symbolic functions, okay, and after that we can write these two differential equations, as you can see at this place. So this is the first differential equation. Diff u is equal to 3u plus 4v. This is the first differential equation. And this is the second differential equation, ODE1 and ODE2. If you have three equations, then you will consider accordingly, okay. Diff v, and diff v is equal to minus 4u plus 3v. So sometimes you have a system of equations or mathematical models. In that case, you have two equations or three equations and multiple equations in the first order or second order. You have to write all these equations systematically, and after that you can store these two both equations in the single assignment by using ODEs, as we do in the previous example for the conditions, okay. But here we have, but in this example we have two differential equations, okay. So this is the first ODE1 and this is the ODE2. But here we are using a semicolon because we have two equations separately, okay. So to represent the equations we need semicolon, okay. So when you will execute this statement, when you will enter these three statements in the MATLAB, this is the output. This is the output. Output means you have two differential equations, and in the MATLAB syntax this will return in this way. You can see diff ut comma t is equal to 3 ut plus 4 product vt, and this is the second equation, okay. So MATLAB will return the differential equations which you insert in the statements will return in this form. After that, how we can solve? You can solve by using this statement dsolve. So when you will use dsolve, this will solve the system of equations, and which returns the solution as element of structures. So this is the solution of the above system of equations, but in the form of element structures, okay. So to extract the solution for u and v, we need some more statement, and how you can use, okay. See here, yes, to extract or access ut and vt, we will use u solution t s dot v, s dot u, okay. S dot u will return the solution for u, and s dot v, this will return the solution for v. See again, that way to use, you can store ut and vt directly by providing the multiple output arguments. See here, this is the u solution t, this is the v solution t, and dsolve. Only this single statement when you will when you have the system of equations, okay, then you can use the statement in this way, and when you will enter, you will get both the solutions. This is the solution for ut, and this is the solution for vt. So this is the simple way to use as we do in the previous statement. Okay, so I think we should examine this in the MATLAB also. See here how you can do in the MATLAB. Control N. Okay, this is the new file, and first we need to save this file with the name of ODE 4. Okay, so here we will do all the steps which are involving in this example. There are some more examples which we do here. So I will start without here we have the solution of a system of differential equations. Okay, system of differential equations. Yes. Okay. So the system of equations are involving two variables. So we are using here Sims, CLC, then clear. Okay, and also close all. You can use close all. Yes, this is very interesting, and you must see and understand the code carefully, how I am doing all these things. First, we need to insert the very first statement. ODE1 is equal to diff u is equal to 3u, 3 product u, plus we have 4v. This is the first statement, and suppress it. Then we have ODE2 is equal to diff v. Okay, and is equal to we have minus 4u, and plus we have 3v, 3 product v. Okay, then we need to store these two differential equations into the single ODEs is equal to, we have ODE1 and use semicolon ODE2. Okay, so if you want to execute, you can check how this will appear. Okay, u is unrecognized. Yes, we have to define both the variables. Sims ux and ut and vt, because here the system of equations are involving u and v and the functions of t. Now execute. Yes, you can see these are the two system of equations. Okay, here also you can use pretty. You know pretty function? I think you know about the pretty function. See what happened when I will use pretty function. Yes. So d upon dt ut is equal to 3 ut for vt. Okay, and this is the second equation. So by using pretty function, you can we have the equations in this form. Okay, so it depends upon you how you want to present your equations, but not required, just for to check it, but not required. Okay, you can remove this statement, and sometimes if you don't want to remove, you can use comment. For the comment, control and R. So this is the comment, and when you will comment the statement, that will not be the part of the programming. Now we want to solve these equations. Okay, but we are not given the conditions. So here what we do, we will find the solutions in the both way. So first we are using this simple way. Okay, so the simple way is first is UT. You can write U solution T. Okay, U solution T. This is the first solution. Then comma and V solution T. This is the second function, and this will be equal to D solve. This will be equal to D solve ODEs. Okay, so this is the complete program, and you can see we have only the few statements, and this will return the solution of the system of equations. Yes, we have this solution. Further, if the conditions are given, if along with the system of equations you have the conditions, okay, so you can apply the conditions also. Here you can display solution without conditions. Okay, and again the conditions we have. How you can insert the statement, and if you have the questions related to this problem, you can put in the chat box so that I can try to justify you. After this one, we will discuss here the matrix method. That is also very interesting. So we are given the condition. Condition 1 is equal to, we have say U0. U0 is equal to, we have 0. This is the first condition, and condition 2 is V0 is equal to 1. Okay, these two conditions are given, and you can use this statement when you have the conditions given. Conditions are given. Okay, so first you need to store these two conditions in the single. I use here conditions. Okay, we can store both the conditions in the single statement by using condition 1 and semicolon condition 2. We have two equations, so we have to use at its place semicolon for both. Okay. Yes, and then you can apply conditions at its place. Conditions, and here we have display. Display, make it correct. Yes, and at its place we have solutions. Okay, this is not allowed. So at its place you can use this one. Yes. Display. Okay, is there? Yes. This is not correct. Yeah. Now check the, yes, you can see this is the first solution, okay, and then after we have solutions with condition. This is the solution without conditions, okay, and after that we have solutions with condition. This is the second part. So both the type of solutions are appeared at this place, and you can write your smart code, beautiful code in the script file, and you can save these files for your future use. Okay, if you have any question, and I will be very happy to see your question in the chat box. Okay, I can hear. Thank you. If you have any question or any problem related to my presentation, I will be very happy to see your questions in the chat box. Yes. Okay. Are you getting the things which I am presenting here? Yes, no? Yes, no, please. Okay. So now, also we can plot the same. If you need to plot, these statements we use for the solution, and these are the conditions. If you want to visualize the solution, you can do. Yes, we are doing. We can plot these solutions of this system of equations. Yes, thank you. Jitendra ji, namaskar. After a long time, I can see you. So if you want to visualize these two solutions, you can do. And how fplot? Fplot is inbuilt function in the MATLAB. You can use. If you have the MATLAB old version before 2016, then you can use ezplot. Okay. You can use ezplot in the place of fplot. So we have fplot. This is the first solution. Plot of this one. Hold on function is used when we have 2 or 3 plots in the same image. In that case, we are using hold on. Okay. So here hold on. This is the second solution. V solution and fplot is there. So fplot, U solution, fplot, V solution used to visualize these two solutions. After that, you can insert some more information to make it more interactive. We can use grid on, we can use legend for U solution, V solution. Okay. So this will make easy to. Yes. Okay. And then after, if you want to fix the location for the legend, you can insert here location west, or you can insert on northwest, southeast, etc. You can do accordingly. Okay. See this visualization code in the MATLAB, because this is very important part for this section. Okay. Yes. So we were doing at this place, and now we need to find out the solution of the system of equations. How we can visualize now? Okay. This is a very important part. Yes. So here what we do, if you will suppress this statement, so this will not return the solutions. We directly want to visualize in the graph. Okay, see, f plot, I am using here f plot for the first solution, which is u s solution t. Okay, you can use only this thing. And when you will execute this statement, you have one graph. You can see this is the graph for only u. Okay, which one is for u and which one is for v. For that purpose, we need to insert here legend. Okay, for that purpose, we are inserting here legend. Okay, so see, first we are doing here grid on, then you can insert here the legend. Legend, then we have u solution. So this will return, this will be used for the first solution. Okay, then we have the v solution, v solution. Then again using the comma, location is best. Now execute this statement. So the most important thing in the sketch file is that we can edit, we can manipulate accordingly. Okay. You can comment all this because we just need to visualize only the graph. So nothing we need to required comment, use the suppress statement. So when using semicolon, that statement will be stored but will not return the value in the command window. Okay. Now we can execute all these statements once again. See carefully all these statements. This is the first, second, third, as we insert sequentially, and these statements are the new for last 4 statement, 5 statement you can see are used to visualize our result. Okay. So here you can see both the graphs are in the same image, and here you can see the grids, the legend. So a blue line is used for u solution, and red line, red curve representing the solution for v. Okay, so in this way we can visualize and make more interactive, informative solution for the system of equations. So you can extend this code for multiple equations, 3 equations, 4 equations, 5 equations, whatever you are given. Okay, so I think this will be very helpful for you, the content which I present here. Okay. Lecture is not breaking from my side. This is a huge system of 100 by 100 system of equations. Yes, we can do, dear Jitendra, but I will try to cover this in the coming session, but presently this will take more time to handle this type of problem. Okay, and your network speed is low. Okay, yes, at some places some participants have the problem, voice is breaking. But from his side, there is no such prompt. It may be prompt from your side. Thank you. And if you have more question, you can put one more interesting example I am going to present here. When you can convert the system of equations in the matrix form. Okay, this will help you in many ways to write your code and to control when you have the multiple equations. Okay, this is the another way to solve the system of equations and the mathematical modeling problems to convert into the matrix format. See in this example. So we have the system of equations at its place. Two equations are there. Dx upon dt is equal to, we have x plus 2y plus 1, and dy upon dt is equal to, we have minus x plus y plus t. So x and y both are the function of a t. We can convert this system of equation in the form of matrix. So this is the matrix format of the above system of equations. So dx upon dt is equal to x dash, and dy upon dt is equal to y dash. So x dash and y dash on the left hand side can be written as in this form, and on the right hand side we can write 1, 2, minus 1 and 1. These are the coefficient of x and y, and these two terms we will insert in this form 1 upon t. So we simply convert the above system of equations in the form of matrix. Now we can easily suppose the y, this one, this is equal to y, this is A matrix and this is B matrix. Okay, so this is y, this is A, this is B. Now the above this is system of equations in the matrix form reduced into this form. Y dash is equal to AY plus B. Okay, so we can easily do in this way. And after that, I will not run this code in the MATLAB, so note all these steps very carefully. And after the session, I will share this presentation in the WhatsApp group. Okay, and I hope all the participants are in the WhatsApp group, so this content which I am presenting you will be very helpful in the for your use. Okay, so MATLAB code is also there and you can use in your MATLAB. So the thing is we have two symbolic functions, xt and yt, according to given the system of equations. So first we need to write this A matrix, and the A matrix you can write in this way, 1 space 2. Okay, 1 space 2 means first row. Either you can use at this place also comma, and a semicolon will break the row. Okay, so this is the second row, minus 1 and 1. Okay, or you can use in the place of space, you can use comma. It depends upon you. And the B matrix, we have this syntax in the MATLAB. B is equal to 1 semicolon T. And this Y matrix we have, Y is equal to X semicolon Y. Now the syntax for this differential equation we have is odds diff y double equal means equal to A product y plus B. So A, Y and B, these are matrices. Okay, so when you are using diff y, this means x dash and y dash. Okay, so AY will be the product of these two matrices, A with B, A with Y. Okay, and then when you will enter this statement, this will return the values. This will return the system of equations. You can see, and these are the same as we are given in the system of equations. Okay, so you can suppress, when you will suppress at its place by using semicolon, then these statements will not appear in the command window. Okay, so this statement, you can save this file, these above statement in the script file. Okay, you can choose any file, and when you will execute this file, you will have this statement will appear in the command window. Okay, and when you will use at its place semicolon, then this will not return. And after that, if you want to solve, the same process we are using here, we have x solution t, y solution t is equal to d solve ODE. Okay, and x solution t we need to simplify, y solution t we need to also simplify, and this will return. These are the codes, these are the inputs, okay, and these are the outputs. So the value of x sin t will be returned at this place, and the value of yt will be returned at this place. Okay, and if along with you are given the conditions, initial conditions, you can use as we do in the previous example. Okay, so all these examples which we present here are similar type, and also if you have the initial conditions, yes, you can see here, these are the initial conditions. Okay, the conditions will be also stored in the form of matrix. This is the first condition for u, and this is the second condition for v. Okay, and y is matrix involving u and v both. So this is the first condition, this is the condition for u, and this is the condition for v. Okay, and you will use this part at its place, and this solo is there. So when you will execute this sequence of statement, and after that, if you want to visualize the same process as we do in the previous example, you can see at its place. There is no difference. Okay, there is no difference. Okay, so I will try to provide this content I will share this file in the WhatsApp group, and I'm not using now the MATLAB to visualize all these results. You should try yourself now. Okay, and I hope you are getting everything. And if you have any question, please you can put in the chat box. If you have any question, more information required, please feel free to ask from me. And I'm waiting from your side. Someone asking about, can you give us an example for solving nonlinear system of equations? By using the same you can use, but if you need example, I can choose in the coming session. Okay, keep in touch and attend all the sessions. There will be several examples, mathematical models, different approaches will be discussed in the coming sessions, and I hope the coming sessions will help you in many ways, will support you. And if you put your questions and send me your prompts, I will be very happy, and I will try to cover all these prompts in the coming sessions. Okay, so thank you very much to see this session till the end.